inside of the brachial valve. So we know that guy was dead. There's 3 Edrios on here, all isotrophous, one little bitty one and two larger ones. This guy, like this previous slide, he's backed by the hinge line. Not too many feeding currents back there to help him out, but that's a nice one. Huh, interesting. Here's 2 really big ones. And what are they on? They're on clams. This is a Carididens clam. You can see them kind of sticking out in different places here. This one's hard to see. You have to actually have the specimen to determine this, because up here this is all bryozoan, which is also a clam. But both of these big boys are on Carididens clams. I didn't photograph because it wasn't that nice looking. I have another kind of a decaying clam picture that has some Edrioasteroids on it as well. Now what do we got? What the devil's going on here? We got Isotrophus on bryozoan. 2 of them. One there and one there. Now this bryozoan is on the Raphnosquena shelf, to be sure. And there's 2 other Edrios that are on the shelf. We got all these Trematus. Some of them are on the shelf. That one over there is on this bryozoan. That seems kind of odd.
Is the bryozoan around it?
What's that? No, no, it is
it's not.
No. Again, you didn't have to see the specimen to see that, but that's a good question because that does happen.
Yeah.
It does happen. This one is arguably on or came from a bryozoan. It's a streptaster. He's kind of squished down on the side. The closest possible place he could have been attached is this, which is a Ramos bryozoan. Maybe not, you know. But my friend Stu does have an Edrio on a Ramos bryozoan, so I don't have a photograph of that, unfortunately. I did not find one like that. Now what do we got? Now we got 2 streptasters, and they're on tremendous inarticulate brachiopods. And they, of course, both those inarticulates, I believe, are on Raphnosquena. So that's, I don't know why they're growing so nice. Here's some other ones. Here's 2 more streptasters. This one is clearly out in the middle of nowhere. Now, without cutting it in half, you can't tell if maybe he's sitting on a shell. He's just kind of got buried with some other stuff. But it looks like he's out in what you would call the matrix. And here again, there's a streptaster on his side. You know, maybe he's in the matrix. Maybe he was on something else. Big Isotrophus over on the one side of this Raphnosquena. I'll also point out in this shot, right here, these little Zygospira, the only other brachiopods in this bed. No Platystrophia, nothing else. It's either Raphnosquena or Zygospira. The other interesting thing about this is that this little rusty-looking thing is a worm burrow for food through the Edrio bed after they've been buried. Okay, so what do these guys really like to attach to? We've seen them attached to all these things. And in the photograph earlier, Bill's was on a cephalopod. Makes you wonder. Maybe they really weren't so careful about what they got on. Maybe they're just opportunists. So let's go a little further. Let's digress and look at mobility. We find really big Edrios, and they're usually a lot of times centered on a Raphnosquena, or they're back away from the margin. And the littler ones are out here by the margin. There's the streptasters and an Isotrophus there. So the thinking that went on here was, you know, how can we find these little guys out here and all the big guys in there, unless the little guy, when he grows, can move in here and then get bigger? Makes sense. You and I used to run these things through our head while we're out there digging, and I was convinced the last time I gave this talk that that's what they did. They moved. Don't know how they moved, but I figured they moved. So, could they really do that? Here's how they grow. Radial growth. They grow out from little, you get bigger, bigger, bigger. One thing about attachment, which we don't know, how did these things stick on whatever they stuck on? We know they're not cemented, because if you pop one off, it doesn't leave, you know, a scar on what it's on. They, I'm just going to speculate, wild speculation here. We could say there's tissue under there. Perhaps this thing keeps some kind of stickiness, some kind of organic adhesive that keeps him attached to whatever he's on. Now that adhesive could be concentrated in the middle. Maybe it's only in the middle, or maybe it's all the way across. But if it's all the way across, they've got to loosen that, so to speak, in order to grow. Or maybe it's not quite sticky enough to prevent them growing outward. Okay, so that's how they have to grow. if you're a little guy and you're out here on the edge and you're going to grow and you're not going to lose it on the, come off the shell, which we haven't really seen that in any of these. So maybe this has got this little variable stickiness going on, and he can still grow radially, but maybe he makes it stick here and loosens up everywhere else. And stepwise, you get one that's like we've seen before, where it's a big one. His margin is down near the shell margin, but the body is primarily centered back further away. That's a possibility. Or here's the moving. Get up and move somehow. Maybe these things had tube feet underneath. That's what was holding them on. If they had tube feet, they could move like a starfish. So here's the case against. And actually, I found this after you left. When I saw this in my slides, I thought, I'm now convinced that they couldn't move. And this is why. There's a carniella and a carniella, and here's an Isoropus trapped between them. And you can see this Isoropus no longer has a circular outline. It's just flat on this side and over here. These guys maybe were all there at one time, or the Isoropus was there first, the carniella started growing, they grew into that Isoropus, and there's a pecking order. Apparently the carniella got the top of the ladder here, and they're intimidating the Isoropus, or however you want to say that, but things do happen in invertebrates. They create chemicals that make the other ones repel them. Whatever reason, this guy's not growing around anymore. And he's probably uncomfortable. And if he was uncomfortable, he'd have moved, but he didn't. And the other thing that supports this is there's some research done by our friend Colin Summerall on some Edrioasteroids, I believe they're Pennsylvania, that are on cobbles, where he sees a lot of this, where one Edrio is being encroached upon by another, and that the other one is getting all squashed up. And in fact, over time, he sees other specimens where one Edrio then starts to grow over the other one. And it's always in a pecking order. It's always this species that restricts the growth of the other one. It's always that same species that overgrows them. Now, I have to go back and look at the collection to see if there's any more of this, but I wasn't looking for it. I think I took this photo because it was kind of neat initially. This is an old photo. So, and again, we know exactly which specimen this is because it's numbered and so on. So my position now is they don't move. Cindy?
Isn't it possible, I mean, there's lots of kinds of limited mobility that you could still get mechanically stuck because you just can't walk around, but
right.
the slow motion of stickiness would not preclude someone from still getting stuck between two, because it could have rims going over top of them and holding them down from doing their locomotion. I understand what you're saying, but I don't think it means it has to not be.
Well, it may not be, but like I say, Colin's study, he's pretty much concluded that. And when Dave and I were talking a few weeks ago, he was saying Colin was pretty much on the side of they don't move.
So do that you find as many hanging over the edge of shells?
I didn't know.
See, that's kind of weird because how when you have that growth pattern moving up, but that.
Yeah,
I
know. I don't think that's a good possibility. I'm just showing that as a maybe, but I don't think that is what happens.
So one on the right, wedging the ISO up.
That's what it looks like. Yeah. Again, I have that specimen for your perusal later, so you can take a look at that.
And we'll score maybe 2-1 at this point.
Okay, but anyway, if this is what this is showing, it'd be the first one that we've been able to show in Cincinnati in doing this. But maybe nobody's been looking for it. Maybe there's lots of them out there. Okay, so here's what we've observed so far. We do know that Edrio is clustered near the opening, the Kamashiro Raphusquina, a lot of places. And the second item there is they do it here every place. There's some scattered all over the Raphusquina shells. We've also seen that they've colonized other substrates besides Raphusquina. And my last one here is that it doesn't look like, at least in this one case, that when their growth is restricted by just another Edrio, that they can move anywhere.
Hey, Jackie.
Yes.
If others did move away, how would you tell?
Well, that's a good point. That's a good point. That's why I think this specimen is important. in that regard, because you couldn't tell.
Could it be that some of them can move and some of them can't?
Well, maybe. I mean, there's a lot of different possibilities along, but you have to be able to, as Dave says, test it. You have to be able to try and look at data and figure out what it is. You know, besides this one specimen here, we have the data, the colonists shown that in these Pennsylvania ones, it didn't move. It got overgrown. And we'll see something a little bit later that may surprise you too. Another interesting specimen. So, can we make a hypothesis that can explain this? You know, one of those neat things that our professional friends like to refer to as Occam's razor. The simplest explanation is usually the right one. And I believe that the explanations I'm going to come up with here is pretty simple.